Anyone? Anyone? You guys doing all right? You guys had a good weekend? Yes?
Number 45.
The one that's the square root of 2t minus 2, that one? So, let me ask you something that should be a very silly question. What is 5 squared? 25. So if I have a 5 sitting there, and then I put a square on it, the answer has to freaking be 25 no matter what, right? And that's the period. Right? No trick question, right? So what's another way to write 5? 2 plus 3 is another way to write 5, right? So if I square it, I better get freaking 25, right? But if you write 4 plus 9, you are not going to get 25, so there must be a wrong thing about this, because we know 5 squared is 25. This is 5, so 5 squared better still be 25. So this means that the math here is incorrect. Not that math suddenly changes mind or something. The squares do not go across additions. So the mistake people make on this problem, all the homeworks are graded so far, I made the same mistake. You squared each piece separately. You're not allowed to do that. Whatever you do to one side, you must also do to the other side. And then, of course, you would have to FOIL. Right? So that's why I say it's instead of squaring all this radical crap together, get at least one of the radicals by itself first. So you don't have radicals acting on other radicals. That just gets crazy. So isolate one of the radicals first and then square both sides. So if you subtract rad t, what can you do then? Square both sides. So if I square this side, I'll do that side. So you have to do half the work. Now if you square this side, what has to, you don't say 49 minus t or something crazy, or 49 plus t. That's, you have to FOIL. That's how you do something. You can't combine these squares. No powers can go across subtraction because they're not based on each other. They're not going to work that nice. You've got to write this sucker twice, FOIL it out. I like it. So see, this one, I would never do this, but it still works. It has to work. This will work. Watch. I don't know if you guys are 4 and 6 and 6 and 9. What's 4 plus 6? 10. What's 6 and 9? 15. What's 10 and 15? Freaking 25. Of course it is. Because that is allowed. That's legal. This, distributing the 2, completely illegal. So of course it's going to come out to a wrong answer. I like it. So you can't just square each piece of this. That makes it a really easy question. Makes it really quick to get to the wrong answer. I don't know why you want to do that. I'm going to get the wrong answer anyway. Might as well do it quick. No, come on. That's crazy. Is that cool? Who asked that question? You did. Does that make sense?
Yes.
So like here, you just write this twice, you FOIL it out. You're still going to have a radical, so again, you get that radical by itself, square both sides.
I get stuck when I get 14 radical t plus t minus 51 plus 0.
So what do we get here? We get 49 minus 7 rad t minus 7 rad t is minus 14 rad t. And then I get plus, what's rad t times rad t? T. I like it. And now you see, you start to, if you haven't started doing this yet, you see why, if you do a lot of math, your t's definitely start to get that curve at the end, so it doesn't look like a freaking plus sign. Why do I plus plus? And then here, you just have to, you get the radical by itself. You don't have to divide by 14. Right? We've done a problem like this before where I said don't just divide by, if it's going to make fractions, there's no need. You just square that piece. So you would, if you subtract 49, subtract t, you get t minus 51 equals negative 14 rad t. And then you square both sides. 14 squared,
Okay.
196. Yeah. Why is that not a surprise? There are 2 square roots. So it shouldn't be a surprise that I'm going to have to square twice in this problem to kill both of them. It's when I have 1 square root, then I only have to square once. Yeah. Okay, maybe. Oh, yeah.
And then you're going to FOIL the t minus
Yep.
again?
Yep. Yeah, Nadia, I haven't done that yet. But now we got a radical. Don't even think about where we came from. Look at where we are. There's a radical. How do I kill it? Square both sides. Don't say, oh, you did. No, it doesn't matter what you did because this is where we are. You do what you have to do with where you are. Yeah. The problem doesn't care that you did it already because it still has this stupid little thing here. I like it. You guys try to finish that out real quick. Let's see. Then we'll do it together. I'm not going to do it until you guys have all tried it. This one gets kind of gross, huh? This is 196 T. And this is about a place where some people just sort of give up and they're like, maybe he won't notice I didn't finish this one. But now what do I have to do? Subtract 196T. T squared minus 298T plus 2601 equals 0. And then this is why I recommend, I mean, I already know one way to factor 2601. It's 51 times 51, but that's not going to help me with 298. So now I just start thinking, okay, what's true about the two numbers? They have to be, do they have to be different signs or the same sign? Which one? The two numbers I need to do this factoring. Different sign? No. Same sign. They're both going to be negative, but all that matters is that the same sign. So they do end up adding to be 298. So just try two numbers that add to be 298. See if it multiplies to be 2601. You could also be smart about the fact that that means that they have to, the last thing has to multiply be something with a 1 at the end. What do I mean by that? So like 140 and 158 added to be 298, right? Okay, good. But it would end in a 0, wouldn't it? When I multiply these together. So screw that. I want it to end in a 1. So me, I'm thinking 149 and 149 maybe. Does that make, yeah, that makes 298. What's 149 times 149? Let's see what that's. Are we close? No. All right, what is it?
149 times 149.
Yes.
5-digit number.
Oh, okay. All right, what is it?
22,200.
22,201? Okay, all right, at least it ends in a 1, right? So now I say, okay, now stay with me now. So now if I do instead, let's try 290 and 8 add up to be 298, right? But what's 290 times 8? Say again?
2,320.
Now we're getting close. We want to get to what? What number am I looking for here? 2601. That's where people just kind of give up, but it's sort of just a number game, really. But do you see, these multiply be really big. So let me make one of them really big and one of them really small. That way they'll multiply be something small. This is way too big, right? I like his face. He's like, no, dude, you're nowhere near. I have no idea. I'm not even thinking about it. Now I'm a lot closer. So, I mean, I don't know. What about 289 and 9?
That works.
Yeah? 2601? Yeah, so it's just a little Price is Right game, to be honest. Higher, lower, higher. Right? I could tell that a lot of you didn't like that, but what do you need to make the factoring work? You need two numbers that multiply to be this. Can you come up with a list of numbers that multiply to this really quickly? 2601? I can't, right? I'm not saying that automatically means you can't, but I know a lot of freaking math, and I would have trouble just coming up with a bunch of numbers that multiply to 2601. It's much easier to come up with a bunch of numbers that add to be 298. I know they have to be the same sign, so they have to add for real. So I tried like right down the middle, and that came out to be stupid big. Okay, let me make one of them big and one of them small. So something like 290 and 8 makes 298. I happen to be close. If this was 3,000, then I would take another step away. I would just kind of keep playing the little game. And you got a freaking calculator. It's not like you're doing all this by hand or something. It just kind of makes me sad that people give up when it's really not hard math. Right? You just want the answer right away now. I think part of it, too, I got a little philosophy about Google and the fact that all the answers for everything are out there somewhere. So students feel like, why would I put this much work into something that somebody's already done somewhere? I think that's in there. It's helping me figure out the way students look at things nowadays. Okay, I'll stop about philosophy and shit. Is that cool? I mean, now how do you factor this then? T minus 289 and T minus 9. So you get T equals 289 and 9. And then you have to check both of them. That's kind of crazy. Wow, 289. That's not something I would have predicted. But it just came out. Yeah. So just test both numbers. One of them works, one of them doesn't. Just to let you know. So remember, radical equations you have to check because radicals have domain issues. So if you do something that makes an answer appear that doesn't work, there's no way you're going to know unless you check it. Okay. Anything else from homework stuff or quiz stuff or? Everybody now. Do you like my t-shirt? It's one of my newer t-shirts. Basketball, parabolic arc. I really doubt that that's what they're thinking when they shoot that sucker. But that's the internalization of math that we do. Our body just internalizes the math for us, thank God. We just know what feels right instead of calculating. Okay. Anything else from anything? Math, homework, quiz? Okay, so we have one last section in chapter 11 that I'm going to make do, and that's 11.5. 11.6, I am making extra credit. You guys understand? So I posted both of those up on my math lab this morning.
So there was a question in my math lab that says find the length of the graph. So
Find the
length.
length.
Yeah, because you put graph and we have to find the length. I don't know.
Oh yeah, yeah. Like they have a line between 2 points, right?
Yeah.
Okay, so that's just what formula do they talk about in that section? They have Pythagorean theorem, but that then leads to this distance formula. Yeah. And the really funny thing about the distance formula, if anything's funny about it, it's let me put an example here. Here's a point xy, x1, y1, let's say, bam. And here's some other point, x2, y2. So, I mean, your brain kind of goes automatically to thinking that it's talking about slope. I'm not. I'm going to talk about distance now between the two, which would be equal to the length of the line if I put a line between them, right? So that really is asking the distance.
I think I didn't know how to find the x and y.
Oh, all right. You got to... Yeah. Did they not give you scale or something? They give you graph, but no...
Just a line.
But no scale. You couldn't, like, read off the points? You'd have to show me that one.
Yeah, I will.
Send me that link, yeah. Okay. But for this one, the distance formula, do you see how I've created a triangle? I don't know if you guys see this. There's a triangle that relates the difference between the x's and the difference in the y's. And this is sort of like slope, right? Rise, run. But we're not going to use it in that way. I want to know, well, how long is this then? We'll call it D for distance. It's crazy, Jeff. I know. So instead of C, what we're used to with Pythagorean theorem. So how long is this side? I know you're all like, I don't freaking know, it's X's and shit. But how long is it? I mean, if that was 7 and that was -1, how long would it be? 8, 7 minus -1. So this is how long is this? X2 minus X1. That's how long it is. So how long is this one? And that's why the ratio of those is the slope, because that's how far I go and how far I go. So that is the length that I travel. You guys still with me? What's Pythagorean theorem say? This squared equals this side squared plus this side squared. So then distance is the square root of that. So they give you 2 points. You plug them in, chug it out, no big deal. But this is a formula based on Pythagorean theorem because there's that hidden triangle, right? Crouching tiger, hidden triangle. No. I try to always work that title into my lecture. So that's just a formula that we now have, that we now know. So it's really just this, C equals square root of A squared plus B squared. That's another way to write Pythagorean theorem. Why don't I put a plus or minus here? Because it's distance. I like it. Don't be telling me you're negative feet away from me. That's going to freak me out. I enjoy it. No, get out of here. Stop it. I watch too many freaky movies. Okay? So there are several problems that deal with the distance formula. Some of you guys found it and realized it's just plug and chug, but I at least want to see one time where it comes from. It's just Pythagorean theorem. It's kind of nifty. Okay. So anything else before we get into sort of new stuff here? We do a real quick, well, let's see. Let's get into the new stuff and then we'll get into the review. So I was just going to do a review of last stuff, but we're going to do that review anyway. So we just barely got into this idea last time. Let's see if they give you. Oh, I see. Okay. I'm going to show you the more general way to do this. I think the book does some weirdness. Let me give you a problem that the book can't even do. So we're going to do it anyway because we're crazy. Well, first of all, let's do a nice simple one. X squared minus 9 less than 0. All right. If it is a parabola, if it is quadratic, we can think of it graphically. I mean, what does this really say? It says, where does a parabola go below the x-axis? That's what it says. If it is equal to 0, that's the x-intercept, so where it hits the x-axis. This is saying, where does the sucker go below the x-axis? Well, which way does this parabola open? Up. So wherever it hits the x-axis, when is it going to be below the x-axis? If it hits the x-axis here and here, it's going to be below it in between those. Is it? Do you guys see? So where does this hit the x-axis? What are the x-intercepts? How do you factor this is really what it means.
X minus 3, x plus 3.
So this parabola would look like this, and when it hit at -3 and 3, is that cool? That's where it would be 0. Now, last time I did this algebraic way, this is more of a graphical way. So I know it would look like this. Whee! Really, just ignore the... I gave it a chin. I don't know. Anyway.
Why did he switch the sign?
Say again?
Why did he switch the sign?
Switch the sign where? Sorry.
Oh, no, I'm not sure.
There's still a less than there, yeah? Yeah, there's still a 3D. So where is this below the x-axis? From -3 to 3. And what symbols are you going to put on those? You want to include those. Those are where it does what? Those are where it... Those are where it does what? At 3, this equals 0. So those are where it equals 0. Is that going to be a part of my answer? Does it want anything to do with equal to 0? No. So what symbols am I going to put on these? Parentheses. Okay. I like it. If it would have been less than or equal to, the only difference would have been bracket, bracket. All right, let me let that soak in there. That's the worst, Jeff. Sink in is better. Okay. If I did the same problem but more algebraically, I would just take what I did. I would do all this work and go one more step with this. This is where it's 0. This is where it's 0. The only place it can become from negative to positive or vice versa is through a 0. It can't be suddenly, you can't go, transport, yay, right? There's no teleportation shit here. You with me? There's no portal guns. Unfortunately, that would be so cool. So if I look at at 0, what's the value of this? At 0, what's the value of this? Negative. You guys with me? That's negative at 0. So it's going to be negative from here to here. Really, you guys, if I'm underneath, if I'm negative, what's the only way I can become positive is if I go through the x-axis. And that means there would have to be an intercept there. So where's the only places it could go from being negative to positive or vice versa? Around here or around here. So if I put one number in, I know it's negative everywhere in here. Because the only way it can become positive is to go through the x-axis. Okay, I like it. This idea of doors through the x-axis. If you're going on to pre-calculus, this can become huge. So what have I put in there? 4. What's the value of this? 4 squared is 16 minus 9.
5.
Yeah, it's positive, right? That's all we care. And negative 4, same thing's going to happen, right? Negative 4 squared is 16 again, minus 9 is positive. So now you look at the question, you say, where is it less than 0? And the answer is wherever it's negative. So it's negative from negative 3 to 3. So if it is parabolic, you can always think of it graphically, right? If it is not parabolic, let me give you an example of one that's not parabolic. You can do parabolic ones this way, and you can also do anything else this way. Anything else you can factor up. So what if I had this one here? Let's do this one. Oh, what you got, Jeff? I don't know, man. Yeah, sure. I like it. Ooh, that's gross. So be a little careful. How do I factor that? Is this parabolic, first off? Is this parabolic? Why do I know it's not parabolic? X cubed, that's not half of that, it's not going to be parabolic. Right? So can you draw it in the air for me? No, you can't. No. It's going to be something, I don't know, it's going to be, who knows? It's going to have some humps somewhere. Where are they? I don't know. How far up do they go? Is it this way or that way? Who knows? Right? Parabolas, it's either sad or happy. You know, there's only two ways it could be. There's a lot more ways this could be. I can't just, know what the graph is. So I need an algebraic way to do this. So what do I do first to factor this? Take an x out. I like it. So everybody just loses an x. And then this guy. You have to add multiply to be 63. There's not that many things that do that. And add to be 16. 9 and 7. I like it. And they both have to be negative. So where is this thing 0? At 9, 7, and 0. Don't forget this little dude. You have control in 3 places here. You can control what x is here. So if you make it 7, make the whole thing 0. If you make x 9, makes the whole. If you make x 0, very directly makes the whole thing 0. But people forget about that poor little. They're like, nobody's with you. Screw you. No. This date is just really shy, right? Doesn't show up. Poor little dude. So he still has a 0. So it's 0 at those 3 locations. That's where it goes through the x-axis. So now I just have to check a number in each of these little pieces. So if I throw in there 10, if I check 10, it's going to be the same sign everywhere because it only can change sign when it goes through the x-axis. So if I throw a 10, I could put a billion in here, doesn't matter, just anything up there. I'm going to put a 10. If I put a 10, I get positive, positive, positive. Do you see that? I don't even care what the number is. I just care that 10 is bigger than 9, 10 is bigger than 7. Positive. So it's positive. What if I put in there an 8? Positive, negative, positive. So it's negative in there. And this is positive forever. What if I put in there, what am I going to put in there? Doesn't matter. 2. Positive, negative, negative. So positive times negative is positive. And finally, if I put in there a negative 1, negative times negative times negative is negative. Do you see how it alternates?
Wait, you multiply?
Oh, sorry. Say again?
Multiply?
Yeah, what's the function doing? What's that function doing? That times that times that. So if I plug a negative 1 in, I get negative times negative times negative is negative. I would get a number, right? I don't care what the number is. Why? Because I could have picked 3 or 4. It doesn't matter what number I pick. It just has to be in here. It doesn't matter what number the output is. It just matters is it positive or negative. Because what's the question really asking? When is this function positive or 0? Well, now I know what it is. Like my 5th puberty. Sorry. Where is it positive? From what to what?
Between 0 and 7.
Between 0 and 7.
And anything above 9, I guess.
Anything above 9, I like it. 9 to infinity. And of course, what am I going to put on these? Why? Because it's allowed to equal 0. And then, of course, here I'm going to put in that, and I'm always going to put that on infinity because I can't get there and pick it up. So this idea doesn't care how big the degree gets. As long as you can factor it and see where the doors are, then you can see, well, is it up here on this side of the door, or is it down there on this side of the door? Because at the very end, you can then just go back. Oh, it wants the positive or 0 ones. There's the positive. There you go. See, that's silly. I don't think you've ever really solved a problem like that, where it's much more visual than just cranking something out. Okay, maybe. Some of you guys are like, okay. Yeah, I see what you did there. So you guys try this one. What you got, Jeff? Yeah, I see. Did I get 1, 2, 4? Yeah, I did. Shoot. Make it x4. I want something specific to happen.
Good job, Joe.
Let's make it less equal to 0. Yeah. Cool.
What do we do with the x squared?
All right, so you can take an x squared out, right?
Yeah.
And then you're left with basically this, just x squared, x, and no x's, right? So then you can just look at the numbers. How do you factor what's left over? X minus 4? X is 1. I like it. So it's the same as this. I mean,
I just do it.
so how many zeros should I get? It makes sense I should get 3 zeros. Right? Now, of course, you know, I'm making these have real zeros. They could have complex zeros, blah, blah. So that wouldn't really come into play. So here I get, what are my zeros? 4?
0 and negative 1.
Yeah, 0 and negative 1. I like it. I like it. So those are the doorways. Those are the doors that you can go from negative to positive. I like it. Because it's related to 0, it's really a question about where is this thing negative or 0. So if you just find the regions where it's negative or 0, that's your answer. So it's a very kind of different way to analyze a problem. So I purposefully did something different here. So again, you just start plugging stuff into from these regions. At 5, what is it? Positive, 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 positive. And then whatever number you want to pick in there, you could use 1.782.
Does it stay a straight line between the 0 and negative 1? Since negative 1 equals 0?
No, it doesn't. It's like, it would, I don't know yet, but it's either going to look like this or the other way. It's going to dip either below or it's going to dip above. And actually, we're going to find out, let me just hold off on that. It's going to do something interesting at 0. So I made it do something interesting at 0. We'll see what that is. But yeah, just because these are at the same level doesn't mean it suddenly becomes a straight line. This thing has to be curved everywhere because of the degree here. Right? So it can't just suddenly become straight for a little while. I mean, that part acts like a straight line. It can't. Okay. There are things called piecewise functions, but we won't go there. So give me a number.
1.
1. That's crazy. So when you plug a 1, you get positive, negative, positive, multiplies to be negative. Is that cool? Positive times negative times positive is negative. There's only one negative, nobody there to kill him. Now let's plug in. What are you going to plug in now? Poor guys. The easiest thing to plug in here would just be like negative 1/2. Is that cool? Negative 1/2. This is always positive. Negative 1/2 minus 4 is negative. Negative minus more is even more negative. So I got positive, negative. Negative 1/2 plus 1 is positive. So I got positive, negative, positive. When you multiply that, you still stay negative. Does everybody see what I'm doing? If you wanted to get the number, you can. You can figure out what the number is. I don't care what the number is. All I care is it positive or is it negative? Because that's really what my question is asking. And then finally, if I put in there negative 2, positive, negative, negative is positive. Now, what I'm about to say is not necessary to do this problem, but I just want to point something out. Did some of you guys notice how this alternated? And every single one of these was to a first power. Do you see that? Right? Where's the only place this didn't alternate? That went from positive to negative. That went from positive to negative. Around 0, it stayed the same. And what's the degree of where the 0 came from? Even. Always. If it's an odd power on the thing where it came from, it's going to change signs. Why? Because what's a line do? It goes through. What's a parabola do? It turns. Or like this, right? So it's going to not change signs. Now, did you have to know what I just said? No. In pre-calculus, you get a lot deeper into it. It's called multiplicity, right? Which is also a good movie with Michael Keaton a long time ago. Creates clones of himself. You can watch it. So what's the answer here? I want less than or equal to 0. So where is it less than or equal to 0? From negative 1. Well, this is interesting.
0.
Yeah, do I have to stop at 0? Isn't it negative or 0 all the way through between those two? All the way. So if you do this, you're not exactly wrong if you do this. But you see how that's kind of silly? Are you skipping 0? No. It's totally included, right? So you should just say negative 1 to 4. Those are the same thing. You don't really skip 0. It's 0 at 0, so it's part of the answer. So a lot of weird things happen in that problem. Yes, sir?
For the second part, I wrote 4 and infinity.
Oh, but this is asking strictly for less than or equal to 0. So that wouldn't be part. That's greater than 0.
Okay.
Not a part of the answer.
All right.
Gotcha. So this one just happened to be contained. Coolness.
So the line would just bounce off the 0?
Exactly. So fourth powers, very often fourth powers look like this. So what this thing does is at 0, it just bounces off. It doesn't go through. It just bounces. Is that cool? And it goes through, negative 1 it goes through, 4 it goes through. At 0 it just bounces. I like it. I like it. And again, you get a lot deeper into this kind of thing in pre-calc, but I just want to give you a little preview. This section should be even easier than what we just did because this section focuses on just quadratic. So you can actually think of it as, does it open up or down? And you can get the answer purely like that. Purely by what it would look like. Okay. Cool. All right. And then I'm going to say a little bit about 11.6, even though I made it extra credit. I don't care. So help me out here. Solve that for me real quick. You should be done. Yeah, you get x.
Negative 8 plus 3.
So you get x equals
8.
I like it. Now, somebody could use quadratic formula on this, right? fact, I could force you to if I wanted to. It'd be silly here. Hopefully you'd agree. It'd be silly because it's freaking easy to factor. But the quadratic formula works for everything. Not just that it works for everything. So what would the quadratic formula look like in this case? X equals... What is quadratic formula? Negative b... I like it. So what's b?
5.
Yeah, negative 5. So negative 5 is 5. Give or take, square root of negative 5 squared, 25 minus 4. All this crap doesn't matter, Jeff. I know. Just put it down there. I'm going to try to make a point. Okay, blah, 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 blah. Why is it x equals this? Because that's what you get here and here. Do you guys see? X equals 8. X equals negative 3. Right? And you're like, well, yeah. Okay. So what about if it was this instead?
Where did you get that 5?
Which one? This one?
That's B.
Yeah, negative b, so negative 5. I like it. So A here would be 1, B is negative 5, C is negative 24.
Well,
So negative 5.
What are you going to do with the 8 and negative 3 then?
Oh, no. Okay. Two different ways to get the answer. If we finish this out, let me finish this out. 5 plus or minus 25 plus 96, I think. Do you guys see that? Negative 4 times negative 24 is plus 96. So 25 plus 96 is 121. Square root of 121 is 11. 5 plus 11 is 16 divided by 2 is 8. 5 minus 11 is negative 6 divided by 2 is negative 3. Are those the same answers we got? Yes. So I did the same problem two different ways. Do you see how that's a lot more than this? Quadratic kicks so much ass when you can't factor, because if you can't factor, you can't do it this way at all. So it kicks major ass. It sucks compared to this if it is factored. That's actually quicker. Okay, is everybody cool with that? So it's not a question of what I was going to do with this. It's like I started the problem over. I said, here's another way I can get the same answers. Right? Okay, so what if I would have had instead this problem? I don't know if you guys remember this. I think I made a point of this earlier this semester, but how do I know the factoring will work for this? The degrees are higher.
Like half.
Yes, the middle power is half. The first, because what do you do? It was like, I'm not sure if I meant that, but I took it anyway. What do you do first with this? Cut it in half. So whatever it is, after you cut it in half, it better agree with what's here, because that's where the middle terms are going to come. So if this was 6, this better be 3. Right? Or else you better hope there's a GCF in there that makes things work. Right? So if the middle power is half the first power, either you can factor it or quadratic formula will actually work. Except here's the difference, though. So this is still going to be minus 8 plus 3. The coefficients didn't change, did they? So they don't give a shit that the powers are different. They just are the numbers that make the coefficients work. That's all they have to do. Then do I get x equals 8 and negative 3? No, I get, what do I get? X squared equals 8. Or x squared equals negative 3. And then I can just square root. So I can take the square root, plus or minus, right? X equals plus or minus 2 rad 2 if you simplify it. What's going to happen over here when it gets square root?
I square root 3.
Beautiful. So plus or minus I rad 3. Is everybody, the only difference really between these two is the fact that this had a higher degree to start with. So the answer is not x equals, it's x squared equals. So here's the point I'm trying to make. If I wanted to use quadratic formula on this, I wouldn't write x equals negative b plus, I would write x squared. Whatever's in the middle, whatever this is. So if that was a 6 and that was a 3, I would write x cubed equals negative b plus or minus blah, 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 blah. That's the point of section 11.6. So I feel okay making that extra credit. It should be relatively easy if you have time. If you don't have time to do it, then you don't have to. You can focus on the other stuff. Okay. So that's all I'll say right there, unless somebody else Somebody has a question about it? No. Okay. So you can try it or not. It's up to you. Yes?
So you was 11.6 on the My Math Lab?
Yes. And I made it 0 weight. So I can still go in and see what you got right and give you extra credit in my spreadsheet. It just won't mess up any grades in the My Math Lab. All right. Anybody not get a copy of the practice test? So everybody got one of those? Okay. I've got the answer key, of course. Oh, by the way, I forgot to say that last quiz, the average was a 78. And that spread number that I said was normally about 11, 12, 13, it was 11.8. So that's a nice spread. There were 3 A's, 8 B's, 4 C's, 4 D's, 2 F's. So a much better distribution. I like that distribution. We can go back and focus on anything you want to focus on now. Yes?
Can I do one practice test, please?
Sure. Yeah.
The domain.
Thank you.
On the quiz.
On the quiz? Oh, yeah.
And what is it to find the domain? I just forgot.
All right, so always, if I ask you, what's the domain of this? So here's what the thing is. The question, what is the domain of this, doesn't always mean the same work is going to be done. It means the same idea is going to happen. What must happen here in this kind of a thing? What must be true for this to work? The bottom
Not equal.
can't be 0. So then you say that, and then you write it in math, and then you solve it, blah, 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 right? And Lewis, you're sitting there like, I didn't have that shit, Jeff. I had radicals. Okay. But it's the same idea, exactly the same idea. What cannot happen here? Or what must be true here? Let me say it like that. I had way too many people writing radicals down when they started doing the domain. No, it's what must be true about the inside. The inside can't be negative, so it must be greater than or equal to 0. So the inside must be greater than or equal to 0, and then you solve it. Period. Why is that true? Why did I say the inside must be at least 0? Two things. When I say domain, I mean real numbers. Right? If I meant complex numbers too, I'd have to say over the complex numbers. That have to be really specific. Secondly, what kind of root is this? Even root. So any even root is going to be uptight. It can't handle negatives. So if this would have been instead cube root of, who cares? All real numbers. You're done. Now there's one kind of nifty one on the practice test. If it would have been this, I like this problem a lot. Is there a problem with the 7th root? No, it's an odd root. It can handle all positives, negatives, zeros. But there is a problem with the inside, dude. Yeah, so then the domain is x can't be 1. Because of this issue. There are two possible issues. One isn't an issue because it's the 7th root. The other one, oh shit, I can't let that bottom be 0. So x can't be 1. That's like one of the problems in the practice test.
So for the g of x, the answer would be x is greater than 7 too.
Yeah,
That's just all you know.
that's it. And you can check it really easy. What's the number less than this? 6 over 2, 3. 3 is less. So if I plug it in, it shouldn't work. It shouldn't come out real. 2 times 3 is 6 minus 7 is negative 1. There you go.
And if it doesn't matter if it's cube or square?
No. That's the point with all this. If it's an odd root, it doesn't have any issues itself.
Oh, the odd.
Yeah. So what else? Anything you've run up across in the homework that gave you trouble? Any process you want to go over again? Any? Yes?
From the quiz, from the practice test, number 3, G.
Oh, yeah, good. That's one that gives people some trouble. So sometimes us math teachers have to be careful how much we do at once, because we're amazing. We can do all this shit in our head, but sometimes it makes students feel like I should be able to do all that shit in my head too. But this one, if you want to see every kind of step so that you're careful, there's really not that much I could do inside. I know you could flip him down, but my idea is if it's all linear already, and that's a negative power, I'm going to bring that in and then just see who's negative now before I start flipping anything. I don't know if that makes sense. Now, of course, you could just bring them down. It wouldn't really change anything. The whole thing would flip. Who cares? But what do I do with that power? Is there anything on the inside really to do? No. So what do I do with that power out there?
Bring it down.
Distribute, right? This is power distribution. Why can't I distribute it here? Because it's multiplication on the inside. And that's what exponents are based on. So it should work well together. So I distribute it. The biggest mistake I see is people multiply and multiply, and that guy stays 8. And that's neat, because the 8's being affected by that dude too, right? So it'd be 8 to the negative 2/3, x to the 2/5 to the negative 2/3, y to the negative 3 to the negative 2/3. That's what you can write for yourself, so you're not trying to do everything at once in your head. All right, raise each piece to the power. Now focus on each piece. Right? How do you do this piece? How do you rewrite this? Eight.
1 over.
1 over. Okay, I like that. Start. 1 over. And what's the root going to be?
0.
Cube root of 8 and
Yeah.
squared. I like it. And then what happens here?
Can I put the square inside? Like,
You totally could. In general, I wouldn't. As some people found out on the quiz. I mean, here it's not that bad. It makes it 64. Cube root of 64, you should know. But what if I had, 64 to the 4/3 power? Do you want to do the cube root of 64 to the 4th? I don't want to figure out what 64 to the 4th is, Jeff. Right? So in general, I put that sucker. So a lot of you guys saw me draw this on your quiz. Put the power on the outside. Holy shit. Remember, I went over that. You're allowed to do it in or out. It has to do with the fact that 4 times a third is the same as a third times 4. Since they're the same, I could put it inside or out. So, let's finish this up here. We'll do those in a second. What is cube root of 8? 2 squared? 4. And then what happens with these powers here? Multiply, so you get x to the
4.
minus
Negative.
negative 4/15. And then here,